All right, the first problem says Mandy's farm has 26 Angus cows and 29 Hereford cows. If each cow must eat 7,200 grams of feed per day, how much feed does Mandy need to feed the cows every day? So we have not two numbers, we have three numbers in this problem. We have 26 Angus cows, we have 29 Hereford cows, those are different species of cow, different types of cows. But then it tells us that each cow in general takes 7,200 grams of feed per day. Now, before we talk about what we need to do, let's just pretend, let's don't read it anymore, and let's just pull the numbers out of the problem and try to write one of these tables on the board and just see what it tells us. Let's first go to 7,200 grams of feed per day, right? So let's take a look at that. Let's say that it's telling us that the cows require 7,200, right? Grams, I think it's grams, let me just double check. Yeah, grams, I'm gonna put grams of feed. The G is grams, grams of feed, okay. And now I'm looking in the problem and trying to figure out what else I can put in there, and it's grams of feed per what? It's grams of feed per every one cow. So it doesn't matter what kind of cow, but we just know that cows in general require this many grams of feed per cow. That's what it's telling us. It doesn't say exactly that. It says if each cow must eat 7,200 grams of feed. Yeah, that's grams per cow. All right, now what do we put over here? Because we have multiple numbers. We have 26 Angus cows, and then we have 29 Hereford cows. But we don't want to put those in separately because we don't want to multiply the cows together. That doesn't make sense. We already know that it requires 7,200 grams of feed per every cow. It doesn't matter the kind of cow. It requires the same amount of food per day. So the first step before we do any multiplying is to figure out the total number of cows we have, because the feed requirement is the same no matter what kind of cow I have in the pasture. So let's go over here and let's say that we have the 26 Angus cows and then we have the 29 of the other kind of cow, the Hereford cows. So it's 26 cows, 29 cows. They're different types of cows, but overall the total number of cows is going to be this. So 9 plus 6 is 15, carry the 1, 2 plus 2 is 4, 1 is 5, so the total is 55 cows. The total number of cows. This is the number we use up here because it requires this much feed per every one cow. It doesn't matter the individual species of cow, the total number of cows is what we care about. So we just go over here and write 55 cows. Why are we writing it up here instead of down below? Well, because up there is the only way that cow will cancel with cow, right? What unit is left? Grams of feed. What is the problem asking me? The problem says, how much feed does Mandy need to feed the cows each day? Because this whole problem is per day. It's 7,200 grams of feed per day. So the whole thing is per day. We want to know how many grams. So what we need to do then for our second step of the problem is to take 7,200 and multiply by 55. Because one cow requires this much feed, 55 cows is going to be 55 times larger. So what do? We multiply 5 times 0. We skip down a little bit. 5 times 0 is 0. 5 times this 0 is also 0. 5 times 2 is 10, so we have to carry a 1. And then 5 times 7, 35. One more is 36. So we're done with that. Now we have to multiply by this. We drop a 0. 5 times 0 is 0. 5 times this 0 is 0. 5 times 2 is 10. 0, carry a 1. 5 times 7, 35. One more, 36. Right? Let's get rid of this. And then we'll go ahead and add these guys up. So all the zeros just add to 0. And then the 6 plus the 0 is 6. And then this 3 is lined up with the 6. That's going to give you a 9. And then the 3 is here. So I get 396,000. What are we talking about? The only unit left, because the cows canceled, is grams of feed. So it's grams of feed. And then you want to double check and make sure that's what your problem is asking. It says, how much feed does Mandy need to feed the cows? Grams of feed is a measurement of how much of it you need. So that's how you do it. It's a two-step problem. But we're not going to always be multiplying. The first step was actually addition, to find out the total number of cows. The second step was to multiply the total number of cows times how much food each cow needs. And if you're not sure if you should multiply or divide here, then you just set this little table up and it tells you 7,200, we divide by 1, that doesn't do anything, times 55. So it's basically these numbers multiplied together. That's what we're going to have to do. So So again, some problems will have addition along with multiplication, some will have other things, but this is the way I want you to do the problems, is to think about the problems. All right, problem number 2. An analyst runs 2 programs. The first takes 36 seconds to run, and the second takes 184 seconds to run. If the analyst runs the 2 programs 175 times each day, how many seconds are the programs running in all? So that's the thing I want you to zero in on. How many seconds are the programs running? That's what I want you to focus on. So we have the first program taking 36 seconds, the second program taking 146 seconds. So together, they're going to take a certain amount of time. And then these 2 programs are run 175 times. So let's start with that. Let's write it down as 175 runs of the 2 program. Let's put it that way. Now, what do we want to write down next door, right? We want to know how many seconds each of these runs take, but we have 2 programs. One is taking 36 seconds per run, and the other program is taking 184 seconds per run. But you see, both of those programs are measured in seconds, and we're running both of them a total of 175 times. So we don't want to multiply by each of these separately. What we want to do is figure out how long does it take both of the programs to run together. Because as a pair, we're going to run both each of them together as a pair 175 times. So the first step actually is not to do any multiplication. The first step is to say that I have a program that takes 184 seconds to run, and the other program takes 36 seconds to run. All right? And I want to know the total number of seconds. So I can put a little s here, 184 seconds, 36 seconds. Let me add these. 6 plus 4, 7, 8, 9, 10, 0, carry a 1. 8, 9, 10, 11, 12, 2, carry a 1, and then I have a 2. So 240 seconds. What does this mean? 220 seconds. I think I said 240. 220 seconds for both of these programs to run as a pair together, right? And I run both of them together as a pair 175 times. 175 runs, and then each one of these runs of the pair takes 220 seconds for every one run of the pair, of both of them as a pair. Because remember, I'm running them both back to back. Why do I write it like this? I could flip it over and put seconds on the bottom and runs on the top, but then nothing would cancel. So it can't be flipped upside down. You must have it where you cancel the units. And then the unit we have left is seconds. It says, how many seconds are the programs running in all? Seconds. That's the unit we want. Seconds is the only unit left. So now what we have to do is multiply the 175 times the 220, which is the same thing as doing 220 times 175. So you can multiply in any order. We will be dividing by 1 in the end. Anything on the bottom you divide by, but dividing by 1 does nothing, just like multiplying by 1 does nothing. So let's write it as 220 times 175. Of course, I could put the 175 on top. It's not going to matter. We're going to get the same answer either way. All right, so 5 times 0, skip down a bit, 0. 5 times 2, 10, carry a 1. 5 times 2, 10, plus 1 is 11. All right, now I'm going to be multiplying by 7, so I'm going to drop a 0. 7 times 0 is 0. 7 times 2 is 14, carry a 1. 7 times 2 is 14, plus 1, 15, so I write the 15 down here. Now I'm going to be multiplying by this 1, so I have to drop 2 zeros. 1 times 0 is 0. 1 times 2 is 2. 1 times 2 is 2. And now I need to add all of these up. So at the end of the day, these zeros give me a 0. These give me a 0 as well. 4 plus 1 is 5. 5, 6, 7, 8 goes here. And then we have 3 here. And the answer is 38,500. What are we talking about? Seconds. Because the only thing left after everything cancels is the unit of seconds. So we put seconds. 38,500 seconds. All right, so for these 2 problems, we had to do 1 step of addition before we do, some kind of multiplication. This next problem, problem 3, I really want you to pay close attention to, because it is going to really, I think, reveal the power of this method that I'm showing you. Because so far the problems are a little simpler and it's easy to think about multiplication versus division. You might already know what to do, and that's great. But when the problems get very complex, especially we get into much more advanced classes, you might not know what to do, and this can reveal to you what to do. So let's read this next problem. It's going to help us. Each year, a second grade teacher has her 22 students bring 18 markers each for the classroom supply box. If she does this for 5 years, how many markers will she collect in all? So in all, we want to have the total amount. But the question is, do we multiply all these numbers together? Do we add some of them first and then multiply? Well, we know we're not going to add anything first because notice when you add or subtract numbers, the units have to be the same in order to add them. See, here we had seconds plus seconds, so we got an answer in seconds. That's why we can really add those. In the first problem, we had different kinds of cows. Cows plus cows still gave us cows, so we can add them. But in this problem, we're not going to add them because everything that we're talking about is different. We have 22 students, and then we have 18 markers, and then we have 5 years. So we know we can't add or subtract those numbers because they don't even match. You know, cows and cows match. Seconds and seconds match. Markers and students and years don't match. So we know right away we can't add them. It doesn't even make sense to add them. So then we start thinking about what do we need to do? We need the total amount. We're probably going to multiply these numbers together. Let's write the table down and see if it actually makes sense with what we think we're going to have to do. So you got to read the problem. It says the teacher or the students, every year the teacher has 22 students. There's 22 students per year. Let's start out that way. So we start out with that first number, 22 students for every 1 year. Because it says right at the beginning, each year the teacher has 22 students bring markers in. Okay. Now, it also says they bring 18 markers. For every one of those students bring 18 markers. So the way you read that is 18 markers per student. 18 markers. Every student brings 18 markers. So it's 18 markers per student. Now I could write markers per student, and then I have students on the top and the bottom. Or I could write students on top and markers on the bottom. But if I write students on the top and markers on the bottom, nothing will cancel. So I'm going to write it the other way. I'm going to say that there are 18 markers per every one student. Again, if I were to flip it the other way, markers on the bottom, nothing would cancel. But this way, I have students on the top and I have students on the bottom, so they go away. So if I do the calculation now, and I'm not done, but if I were to be done, if I just stop right here, then 22 times 18, and then I would divide by 1, but the dividing by 1 does nothing. So if I did 22 times 18, what would I get? The only unit left is the number of markers per year. That's what I would get. So if the problem were different and the problem said, how many markers per year do the students bring? Then you would just multiply them because you know that there's 22 students in every year, and then there's 18 markers for every student. So when you multiply it out, you get this times this, and the answer is in markers per year. But that's not what we want because it says she does it for 5 years. So after the first year, and then the second year, and then the third and fourth, and the fifth year, what's the total number of markers? So we have one more thing here. You see, you can chain these together. You can extend this table as far as you want. We're doing this over 5 years. We're going to put it on the top. Why? Why am I putting it on the top? Why don't I put it on the bottom? Because when I put it on the top, years is on the bottom here. It will cancel with the years on the top here. That's why I do it that way. If I put the years on the bottom, nothing else cancels, but it has to cancel because now what unit am I left with? Only markers is left. The problem says how many markers will she collect? How many markers total? So when I do it this way, the only thing left is markers total. So I know that I have to take the 22 and then times the 18 and then times 5. Everything on the top gets multiplied. Everything on the bottom you divide by those, but there's just ones down there, so they don't do anything. So what we're going to do to solve this problem is we're going to take the 22 times the 18. Now, a lot of you might have thought, well, this makes sense. I would have known that anyway. I mean, that's great. If you can read the problem and you know that you have to multiply all these numbers, fantastic. I'm actually really happy for you. But you're going to trust me here. You have to trust me that doing it this way is going to reveal so much more power as you get into more complicated problems that aren't so easy for us to understand. So we have 8 times 2. That is 16. So we skip down a little bit, carry a 1. 8 times 2 is also 16. 1 more is 17. Now we drop a 0. 1 times 2 is 2. 1 times 2 is 2. And then we add. 6 goes here. 7, 8, 9 goes here. 2 plus 1 is 3. And the answer we get is 396. Now, what is the unit associated with this? Remember, all we did was this times this. So it's like this is gone. So if we stop here, remember, if we don't have this with a strike through, the answer is in markers per year. So the 396, that's how many markers per year. It's in markers per year because you have 22 students in a year and every one of them brings 18 markers. So it's that many, 396 markers for the entire year. But then we're going to take this number, the 396, and we're going to multiply by 5. Because over 5 years, that's the total. And then what we get is 5 times 6 is 30, carry a 3. 9 times 5, 45, then we go up, 46, 47, 48. Put an 8, carry a 4 for 48. 5 times 3 is 15, 16, 17, 18, 19. And then we have 1,980. What unit do we have here? Well, now everything is canceled. We did this times this. That gives us this. Then we take that answer, multiply by 5. The only unit left is markers. And that's the answer, 1,980 markers total over 5 years. And again, I'm going to say it again. A lot of you would read this and say, well, I know I have to multiply. And that's fantastic, that's great. But I do want you to understand what I'm doing because as we get into more complicated math, it's going to be extremely powerful. All right, problem number 4. There are 1,273 students at the middle school and they each eat 2 meals at the school every day. How many meals will the cafeteria have to prepare over 5 days? Right? So first you might think, maybe I have to add or subtract something. Let's look at these numbers. Remember, in order to add or subtract anything, the units have to be the same. Just like, here, seconds, we could add to seconds, and in the first problem, cows, we could add to cows. Let's check this. 1,273 students, 2 meals, 5 days. So we have students, we have meals, we have days. We cannot add those numbers because they're different things. You can only really add things, you can add apples to apples or oranges to oranges. But if you try to add apples to oranges, then what you really are adding is fruit to fruit, right? Because you can't add things that are different. They have to be the same thing, right? So we know we're not going to add. So let's see if multiplying makes sense. So let's just write it down and see what happens. 1,273, it says students at the middle school. And then it says, let's see here, they're students at the middle school. They each eat 2 meals at the school every day. How many meals will the cafeteria have to prepare over 5 days? So really, we're talking about days. There are 1,273 students in every single day. So you put over 1 day. So would you agree there's 1,273 students per day, every day, right? Now, what's the next thing? All right, now the next problem says, or the next part says, they each eat 2 meals at the school every day. Now there's this many students, each of those students eat 2 meals. So the students have 2 meals per student, right? So I'm going to write that down as 2 meals per every 1 student. Okay, why am I writing it like this? Because doing it that way means students cancels with students. Now, if I were to stop here and say this times this, the answer I'm going to get is meals per day. That makes sense, right? If I have 1,273 students, everybody gets 2 meals a day, then I multiply, that's how many meals are served every day. But the problem doesn't want that. The problem says how many meals does the cafeteria make over 5 days? So this is how many meals per day if I were to stop there, but I'm not going to stop there because the problem wants to know over a 5-day period. So I just put 5 days up here. I mean, why do I put it up there instead of down there? Because this is the only way that days will cancel with days. And now the only thing I'm left with is meals. So what I'm doing is I know that I have this many students, and I know that every one of them gets 2 meals every day. So I'm going to multiply these first, get the answer, and then multiply by this. So 1,273 times 2. All right, what do we get? 3 times 2 is 6. 7 times 2, 14. Carry the 1. 2 times 2 is 4, 1 more, 5. 2 times 1 is 2. So I have 2,546 what? Because if I stop here, what do I have? Meals per day. Meals per day. Meals per day. But I don't want to know meals per day. I want to know after 1 day, after 2, 3, 4, 5 days. So I'm going to take the meals per day multiplied by 5 days. And I have 2,546 meals per day times 5 days. All right, 6 times 5 is 30, carry the 3. 5 times 4 is 20, plus 3, 23. 5 times 5, 25, 26, 27. And then 2 times 5 is 10, 11, 12. 12,730 what? After I multiply by 5, days cancels with days, students cancels with students, meals is left. 12,730 meals. So the table, the conversion table tells us what to do, but also it makes sense what to do. Because if you have this many students and this many meals served per student per day, every day, then when you multiply this, you're going to get meals per day. And then when you get the meals per day, then you multiplying over a 5-day period gets you the total number of meals served. All right? Problem number 5, last problem. It says a bakery sold 285 dozen cookies last month. That's a lot of cookies. For $14 for each dozen. If it spent $855 on ingredients and supplies, how much did the bakery have left? How much did the bakery have left? So you got to think a little bit logically about what this is asking us to do. First of all, we have dozens of cookies, we have dollars per dozen, and then we have dollars. So we can't really add or subtract. It seems like you can, but when they have $14 for each dozen, that's a price of $14 per dozen. Then we have $855. That's not dollars per anything. So the units are actually different, and we can't really subtract or add right away. You can't add dollars per dozen or subtract dollars per dozen and dollars. It doesn't make sense. They're not the exact same unit. So let's think about what we need to do. We have 285 dozen cookies, and we know the price per dozen. So let's figure out what the cost or how much money we earned that day. We know that we sold 285, I'm going to put this as D-O-Z, that's dozen, 285 dozen. I know that that's how many dozen I sold. The price was $14 for each dozen. That means $14 per dozen. So $14 per every one dozen. Now I could flip it over with dollars on the bottom, but then nothing would cancel. So I don't do that. I do it this way. Dozens cancel with dozens. Now why am I doing this? Because if I do this calculation, it's telling me to multiply these numbers and then divide by 1, which does nothing. And the unit I'm going to get is dollars. That's how much money I'm going to take in from the customers, right? And so let's calculate that first. Let's look at 285 dozen, and I'm going to multiply that by $14 per dozen. That's going to tell me how much money I actually pull in from the cash register. 5 times 4 is 20, carry the 2. 8 times 4, 32, 33, 34. 2 times 4 is 8, 9, 10, 11. 11 gets written down here. And now I'm going to be multiplying by 1, so drop a 0. 1 times 5 is 5. 1 times 8 is 8. 1 times 2 is 2. And I'm going to be adding all of these numbers together. So what do I get? I get a 0 here. 4 and 5 is 9. 8 and 1 is also 9. And then 1 and 2 is 3. So I have 3,990 what? What have I calculated here? Dozens cancels with dozens. The only thing left is dollars. So this is dollars. So this isn't the answer though, because that's how much money I make. That's when the customers come in and pay me money, that's how much money I make. But it says that I spent $855 on ingredients, right? Because when you have a business, you have to buy the flour and the sugar and the eggs, right? You have to buy that stuff. It cost $855. So how much money I really make is how much money the customer gives me minus how much money it costs. So it's going to be a 3,990, 3,990 minus 855. 855. Now, does it make sense to subtract these? Because yes, it does. Because this is 3,990. This is dollars. And this is $855. Right? We can subtract them because they're the same unit. All right, 0 minus 5, can't do that. Make it a 10. Borrow, make that an 8. 10 minus 5 is 5. 8 minus 5 is 3. 9 minus 8 is 1. 3 minus 0 is 3. So 3,135, what? Dollars minus dollars is still dollars. Right? Notice in order to subtract these, I had to have dollars minus dollars. just like I had cows minus cows, just like I had seconds or cows plus cows, and then seconds plus seconds. To add or subtract numbers, they have to be the same unit. So we can do that subtraction, but before we do it, we have to figure out how much dollars we make. So we set this up as a multiplication. This is the total number of dollars. Subtract how much cost of ingredients in dollars, and what is left over is what you call your profit. That's how much money you make from your business after you pay everybody, or after you pay for the ingredients anyway. All right, that was multiplication word problems part 2. They were a little bit more complicated, but I'm glad we're doing them because I can show you how to use these tools that we now have to solve problems that are a little more complicated than we've been doing in the past. So now we've done a great review of multiplication at this level, pretty extensive. And what I need you to do now is solve all of these problems. Make sure you understand, get the right answer, make sure your skills are good and where they need to be with multiplication. Follow me on to the next lesson. We're going to do a really great comprehensive review and practice of your skills in division. Learn anything at mathandscience.com.